Hey everyone, in this video, let's look at another machine learning algorithm called k-means clustering. The k-means clustering is an unsupervised machine learning algorithm that can be used to cluster data. Till this point, we have seen supervised machine learning algorithms. So now let's look at the unsupervised machine learning algorithm called k-means clustering. First, let us look at the theoretical part of how k-means clustering algorithm works, and in the later part of the video, let's implement it. So before we jump into the theoretical part, first we need to understand the difference between classification and clustering. The models that we created earlier were based on supervised machine learning algorithms. So they were used to classify and predict data values. Here we are going to cluster the data points since it is a unsupervised machine learning algorithm. So let us know the difference between clustering and classification. In clustering, the goal is to group similar data points together without any predefined labels. The algorithm tries to discover inherent patterns, structures, or relationships in the data. Whereas in classification, the goal is to predict the class or category of a particular data point based on its feature using model or trained labeled data. So the point is, here we are not going to classify any data points based on its class or where it belongs. Here we are just going to group similar data points together in which the data set does not have any predefined labels for the target. So we will be having some random data points or values in our data set that can be grouped to a similar type. So there can be any number of groups of data points that can be similar. So we have to identify the respective data points and cluster them together. So this particular process is called clustering, and k-means clustering is one of the clustering algorithms that we are going to see. To explain this particular algorithm, I have taken a dataset from Kaggle called wine dataset for clustering. I took this particular dataset because it contains unsupervised data where we have various features of chemical compositions of particular wine. So based on these particular chemical compositions, we have to categorize or cluster similar kind of wines together. I took this particular dataset because it is easy to understand. We can easily cluster the similar data points together based on these chemical compositions. So this particular data set we will be using for this particular algorithm. So now let's jump into the theoretical part and let's know how k-means clustering algorithm works. Now consider a data set that has data points like this when visualized. Here, to know the difference between the data points, I have used two different colors. The red colored data points represent a separate category and the green colored data points represent a separate category. Our aim is to group these data points into a cluster. So we will be grouping something like this. All these red colored data points should be a separate group and all these green colored data points to be a separate group. This is what we do in k-means clustering. To do this, we will be following certain approaches. In k-means clustering, first we will be plotting two random centroids between the data points. So it will be something like this. Initially, we will be choosing some random centroids. Consider the centroid to be here and another centroid to be here. Now we will be joining these 2 points and we will be drawing a perpendicular bisector between these points. So in k-means clustering, all these data points behind this line will be considered to be a separate group. All these data points behind that perpendicular line will be considered as a separate group, and all these data points will be considered to be a different group. This does not stop here. What we will be doing is that we will be finding the average value of these data points. The average value of these data points will be somewhere here. Consider the average value of these data points to be here and the respective mean value of these data points to be here. So what k-means clustering algorithm does is that it will join these two particular line and it will be drawing another perpendicular line. So what happens? Previously we had some red color data points in the green color category and some green color data points in the red color category. So this is not right. We have to group all the data points which are similar together. We should form a cluster such that only similar data points are present in the cluster. So now what happens? All these data points behind this line will be considered as a separate group. And these data points will be considered as a separate cluster. So this is what happens in k-means clustering algorithm. So now look, this green color data point will be categorized as red color data point in the second iteration. And this red color data point will be classified, grouped into green colored cluster. So again in this particular cluster, the average value will be calculated. So now the mean value will be somewhere here. And this particular mean value will be here. So now k-means clustering algorithm again draws a perpendicular line and a bisector for that. This process will be recursively done until all the data points are grouped together, until no specific point is clustered in a different group. So this is the overall idea of how k-means clustering algorithm works. So here we easily identified that there are only two clusters. Consider this to be example so that it had two clusters and we understood how k-means clustering algorithm works. So in the real time, we will not be able to know how many clusters are present. So in the k-means clustering algorithm, k is the number of clusters that are present in our data points. So we have to find the value of k. The value of k decides that how many clusters are present in our data set. In order to find the optimal value of k, we will be following a certain approach called elbow method. The elbow method is used to find the optimal value for k. Since this is an unsupervised machine learning algorithm, we will not be sure that how many clusters that is going to be present in our dataset. So it is an important step to note to choose the value of k. The value of k will be obtained using this elbow method. In elbow method, we will be visualizing a graph where we have a value called WCSS, and the value of k. While visualizing this WCSS and the value of k, we will be getting a graph like this. Since this graph represents a figure like elbow, this particular value, which is called the elbow point, will be taken as the optimal value for k. So before doing this elbow method, we need to understand what WCSS is. WCSS stands for within cluster sum of squares. So let me take a new whiteboard to explain this WCSS. So WCSS stands for within cluster sum of squares. Here, consider data points like this. Consider we have a centroid here. In WCSS, we will be calculating all the distances between the data points and the centroid's distance. The WCSS is given by the formula WCSS is equal to summation of I equal to 1 to n distance of xi comma c the whole square. Here first we have to find the distance between the data point. Xi represents the data point and c represents the centroid, and we will be squaring the distance for all the data points that is present in our data set. So first consider we have only one centroid. Here we will be calculating all the distances between the centroids and the data points using this particular formula. So if we have only one centroid, the value of the WCSS will be very high. The value of WC will be very high for one centroid. Consider we have two centroids. Here we will be calculating this particular centroid's distance here. So the value of WCSS reduces with respect to centroids. So we will be getting a graph like this. Here we will be having WCSS and the k in the x-axis. So the value of WCSS reduces as the k value increases. At a certain point, it reduces rapidly and the slope gradually decreases. So this particular point where the graph decreases abruptly, this is the optimal value for k. So using this, we can decide which particular value of k or how many clusters that is going to be present in our k-means clustering algorithm. As you can see, if the number of centroids is increased, consider we have 3 or 4 or 5 centroids here, the distance between the centroids and the data points will be reduced eventually. So more the number of centroids, less the distance. Hence the graph decreases here, and it is not the right value to choose k. And if the number of centroids is very less, the value of WCSS will be very high. That is not optimal. So we have to choose this particular elbow point to choose the right value for k. Here, to calculate the distance between the centroids and the data points, we will be using Euclidean distance. Or we can also use another metrics like Manhattan distance or Minkowski or Hamming distance. But mostly we prefer Euclidean distance. I have discussed how Euclidean distance and other distance metrics works in my previous video. If you haven't watched my previous video, please do check my previous video. So once we got the value of k using this elbow method, we can determine the number of clusters in our dataset, and we can easily cluster or group the data points based on the value of k. So this is how the k-means clustering algorithm works. Now we have an overview of how k-means clustering algorithm works. Now we can jump into the implementation. Here I have imported all the necessary libraries. Now I am reading the CSV file. Once I read the CSV file, I am checking for the correlation between the features. Here I am checking the correlation between features to do feature engineering. If two features are highly correlated, we can drop either one of them, because more the number of features in our model increases the complexity. Here I am visualizing the correlation matrix. Visualizing in correlation matrix might be a bit difficult, so we will be implementing a visualization for the correlation. Here I will be using heat map. Here we can see the values that are in dark red color to be highly correlated. So I will be dropping the highly correlated features. Here we can see that these chemical components, flavonoids and total phenols are highly correlated, and it has a value of 0.86, which is near to 1. So we can drop either one of them because they are highly correlated, and I found those similar features which can be dropped. So I'll be dropping these 4 features from our dataset. Then I'm checking for outliers. Here I'll be using box plot to visualize if there are any outliers present in our dataset. So here we can see some outliers are present in the particular box plot for you. There is a particular outlier in our dataset, and there are another outliers in color intensity. So here I'm finding outliers and I'll be fixing it. Here I'll be using z-score to deal with the outliers. Z-score is nothing but a standardization method. Here using z-score, we will be transforming the data set value such that the data set value is subtracted from mean value and divided by the standard deviation, such that we can standardize the data and we can set a threshold to 3. If the value of the data after transforming is either above 3 or negative 3, then we can consider it to be an outlier. So here I will be uploading all this code to my GitHub account, and I have discussed about data pre-processing, feature engineering and dealing with outliers in my previous video. If you haven't checked my previous video, please do check it, where I explained how to pre-process data. Here I am analyzing the data after fixing outliers. So now let's create an instance of k-means clustering algorithm. But before that, I will normalize the data such that it increases the efficiency while creating the instance. Here I have normalized my data set. Then before implementing the model, we have to find the k value. For that, I will be creating an empty array for WCSS values. So I'll be using a simple for loop, and I'll be giving the range 1 to 10 to decide the k value. So here I have created the instance by creating a model inside the for loop. Here we create the instance of k-means algorithm for every iteration. This iteration creates instance such that the model gets created for every k value that we gave in the loop. So this loop runs for k value 1 to 10, where the number of clusters inside the model varies from the loop, where the value of k increases in each iteration. And I am fitting the data to the instance, and every time I will be appending this particular WCSS value. This particular k-means dot inertia, this method appends the WCSS value. This k-means dot inertia is nothing but the WCSS values. Here scikit-learn's k-means algorithm automatically gives us the value of WCSS. So this particular line will append the WCSS value every time using this particular method. So now let's visualize this. Here I'm getting some warnings. This is because scikit-learn is going to be updated. So these are future warnings. So let's ignore these warnings and let's get into the elbow method. Here we can see the graph that I told. This particular graph looks like an elbow. Here we are able to see that the graph abruptly decreases after this particular point. So we can see the elbow point here. It is reducing gradually, and after this point it is reducing rapidly. So this particular point is called elbow point. Here we got the value 3, and here the value of 3 is correct. I am saying this confidently because in the dataset itself they have mentioned that they have 3 different types of wine cultivars. So since they mentioned here, we are confident that the value of the k is 3. So now that our model has a correct k value, we can proceed further. So I have declared the optimal k value as 3. So now I am creating a model with a particular k value. Here I am giving k value as 3 and random state 42. Now I am predicting the data. As a result, I am adding a new column to our data set called the cluster. This cluster column will be adding the predicted value to our data set. So let's visualize our data after adding that particular cluster. So here we can see that the last column has a cluster and it mentions 1. It is nothing but this particular record belongs to a cluster 1, and this we can see here cluster 2. This particular record belongs to the cluster 2. Our model has classified that these data points, I mean these features belong to a category 2 or cluster 2. So now we are done with the model that has predicted our data points. We have trained our model with all these 9 features. So now let's visualize how our model clustered the data points. So here I am visualizing the data before clustering. I have taken these two features for visualization. Here we can see alcohol with color intensity. This is how our data points look when visualized with respect to these two features. Now let's look how it looks after clustering. So I have written the particular code to visualize how our data looks after clustering. So here we can see that our data is clustered these points together. These particular points to be in blue colored belongs to a separate cluster. All these red points belong to a separate cluster, and all these green colored points belong to a separate cluster. Here we can see that there are some data points that belong to the middle region, but they are grouped under different cluster. This is because we have chosen this particular two features to visualize. You can do different combinations to visualize these data points such that we can get a better visualization of this clustering. So let me take another set of features to visualize. Here I have taken magnesium. I forgot to change the name of this particular y-axis. So here we can see that all these blue colored data points in the left side to be a separate cluster, all these data points in the red and all these data points in green. So this is how our k-means clustering algorithm works. Let us find the accuracy of this particular model that we created. Since this is an unsupervised machine learning algorithm, we cannot calculate the accuracy because if we had a target variable or target feature, then we can find the accuracy of our algorithm. Since this is unsupervised and we do not have any target feature, it is not possible to calculate the accuracy exactly. So we will be using some metric called a silhouette score. This is not exactly accuracy, but this particular score gives us how well the model is built, or in simple words, it gives the quality of the model, whether this particular model has a good quality in clustering the data points. So using this, we got a score of 0.52. In silhouette score, we will be getting quality scores from the range -1 to 1. So 1 represents that the model has clustered the data such that the distance between the clusters centroid and the data points is very huge. So 1 is not right. So -1 also represents that the model is not right. So the optimal value is 0. So we got a score between 0 and 1. Closer the value to the 0, the better quality that our model has been created. So 0.52 is a good score. Let us know how silhouette score works in the upcoming videos. For now, let's understand that the score is good. So let me visualize it this particular scatter plot so that we can understand much better that how our model has clustered. Here I will be using alcohol with flavonoids. These two can give better visualization. Yes, here we got a better visualization. Here we can see that these blue color data points to be a separate cluster, and this green color data points to be a separate cluster, and this red color. We can also visualize the centroids of these particular clusters. So I have written the particular logic for visualizing the data points along with its centroids. Again, I will be uploading this code in GitHub. You can always refer there. So these stars in yellow color represents the centroid. Here you can see that after a number of iterations, our model has created a clustering algorithm that has grouped our data points into different clusters. So this particular centroid is responsible for this blue colored, and this centroid for red color, and this for green color. So it calculates the distance between these data points such that it groups it together. It is always better to know how the hyperparameters of every model works. You can also tune them and make the efficiency of the model to be much better. Here our model found that the optimal k value is 3 using elbow method, and we have created 3 clusters for different data points. So I hope you understand how k-means clustering algorithm works theoretically and practically. Here we understood how k-means clustering algorithm works, and we pre-process the data. You can also use principal component analysis for feature engineering. Always check for correlation between features. We done heat map correlation between data sets, and we found outliers and fixed them. We have also done min-max scalar and found WCSS values and how it works and visualized them. And we created models for different k values using iterations. and we visualize the data before clustering and after clustering. So that's all for this video. Hope you understood how this particular algorithm works. So that's all for this video. See you in the next video.